Okay, so continuing on with this problem, we are then going to use this right triangle to help us solve for x. Now that side length of x is also this side here, and then we have OP being 40. And then what I would do to find the to find this other green side is I would do 31, the radius of the larger circle minus the radius of my smaller circle, which is 7. And so this ends up being 24. Again, not drawn to scale. So in this green right triangle, the x and the 24 are the legs. So I'm going to do an x squared plus a 24 squared. And that would equal my hypotenuse of 40 squared. So I have an x squared plus a 576 is equal to 1600. Subtracting that 576 over, I wind up with x squared is equal to 1024. And taking the square root of both sides, 1024 is a perfect square. X comes out to be 32, which is the length of xy, and that's what I was trying to find. Okay, moving on to the next problem. So for this one, we have all these lines being tangent. So since BC and DC intersect at C, that means that they're congruent. And since FE and ED both intersect at E, they're congruent as well. And it says EF is 24. A to E, so let me draw that in, is 25. And AE to AC has a ratio of 1 to 3. So what that would mean is that if I take AE, which is 25, and I multiply it by 3, I would get AC to be 75. Another thing that we can find right away is that ED, since FE is 24, then ED is 24. So that's something that we can deal with right away. So they want us to find the radius of the circle. They also want us to find BC, rounded to the nearest hundredth. And then they also want us to find EC. So let's get started. So let's first start on the radius. Well, if I connect A to B, actually, let's do it differently. I'm going to connect A to D. Or you can connect A to F, doesn't matter. But if I connect a radius to a tangent, remember that creates a right angle. So now I can use the Pythagorean theorem to help me find the radius, which I'm going to label as x. This is actually a Pythagorean triple. This is a 7, 24, 25 Pythagorean triple. So the radius is 7. So then to find BC, I'm going to connect A to B. And that's also a radius, so I know that that's 7. And again, a radius to a tangent creates a right angle. So now I can use the Pythagorean theorem on this yellow right triangle to help me find BC, which I'm going to label as y. So I'm going to do a y squared plus a 7 squared is equal to a 75 squared. This is not a Pythagorean triple. So I have a y squared plus a 49 is equal to a 5,625. Subtracting 49 from both sides, I get y squared is equal to a 5,576. And then it does say to round to the nearest hundredth, so I'm not putting this in simplest radical form when I take the square root. I'm just going to type in the square root of this in my calculator and round. So y comes out to be about a 74.68. Sorry, 67. I rounded wrong. So BC is what I labeled y. That's a 74.67. Now they want you to find EC, which, since BC and DC are congruent, that would mean that DC is about a 74.67. And to find EC, all I'm going to do is I'm going to add the 24 to that 74.67. And that gives me about a 98.67. All right, that brings us to the end of video number 3.